two words. Redox comes from reduction and oxidation. Redox. So that reduction and oxidation can be explained in a few ways. Now, if it is regarding oxygen, addition of oxygen is an oxidation, while removal of oxygen is a reduction. So, if you look at that, oxidation, one method is addition of oxygen is an oxidation. Removal of oxygen is a reduction. Removal of oxygen is a reduction. If we use hydrogen for this, addition of hydrogen is a reduction, right? Removal of hydrogen is an oxidation, while addition of hydrogen is a reduction. Okay. The other way, and the very correct way, is about gaining and removal of electrons. So what we call oxidizing substance is removal of electrons. So when the electrons are removed, we call it an oxidation. Removal of electrons. And if the electrons are added, or an atom, if an atom obtain electrons, we call it a reduction, gaining of electrons. That's how we define oxidation and reduction in three methods. Now look at the exercise in your book, question. Page number 107, right? First one, A. In each of the following questions, state which reactant has been oxidized. The first one, lead oxide, hydrogen. Then the products are hydrogen and water. So you can see there, from lead oxide, oxygen has been removed. So a removal of oxygen is a reduction. So the first one is a reduction. Then look at the second one, carbon monoxide and silver oxide. You can see there, at the first one you can see that the lead oxide, the lead is reduced while hydrogen is oxidized. So the question is to mention the reactant which has been oxidized. So in the first one, hydrogen is oxidized. Second one, silver is reduced, but carbon monoxide is oxidized because it becomes carbon dioxide. Third one, magnesium reacts with carbon dioxide, and the products are magnesium oxide and carbon. Their carbon has been reduced. So magnesium is oxidized there. Part B, there you have to select which reactant has been reduced. So in the first one, iodine with oxygen, that compound, oxygen is removed there, so that is reduced. Number 2, hydrogen sulfide and sulfur dioxide is there. You can see the sulfur dioxide oxygen has been removed. For that, because of that, it is a reduction. Okay, and the next one is two carbon atoms, that is ethene, right? Ethene with hydrogen. So there is addition of hydrogen. So addition of hydrogen is we know that's a reduction. So ethene there is reduced. We know that in redox reactions, oxidation and reduction occur. That means removal of electrons and gaining of electrons. So here I will write a reaction. We know that we burn magnesium strips in the lab. So magnesium reacts with oxygen to form magnesium oxide. While that occurs, another reaction occurs like this. Magnesium reacts with nitrogen and magnesium nitride is formed. Magnesium nitride is formed, right? So that to balance we can put like here 3. So this is the balanced equation. So here an oxidation and reduction is involved. What is the oxidation? Oxidation means removal of electrons. So here what removes electrons? Magnesium remove electrons. Magnesium remove 2 electrons to become magnesium ion. While nitrogen nitrogen gains 3 electrons and becomes the nitride ion. So there are 2 reactions. This is oxidation reaction and this is the reduction reaction. So we can call these half reactions. So a redox reaction contains 2 half reactions, in which one is an oxidation reaction, the other one is the reduction half reaction. So in our book, sodium chloride is given. You can look at that. Sodium remove 1 electron and chlorine gain 1 electron, and simply the sodium positive ion and chloride ion are formed. Here I give a little different one where magnesium remove 2 electrons, nitrogen gains 3 electrons. Anyhow, here the half reactions are clear. You can see the half reactions, and now we have to balance these half reactions. Now in that sodium chloride one, the half reaction is not to be balanced because already that is balanced. Sodium removes 1 electron and chlorine gains 1 electron. So that nothing to be balanced. Here when magnesium removes 2 electrons, nitrogen gains 3, so that we have to balance this using the electrons, right? So it's better to take the lowest common multiple of these 2 and 3. So you know that is 6. So make this 6. What can you do to make it 6? You can multiply this by 3, and to make this 6 you can multiply by 2. The whole half equation is multiplied. So this becomes 3 magnesium, 6 electrons, 3 magnesium ions. Here 2 nitrogen, 6 electrons, 2 nitride ions. Then you can add them together, and electrons are then cancelled because 6 electrons each, and you get this equation. Then 3 magnesium, 2 nitrogen, 3 magnesium ions and 2 nitride ions. So that's how the redox reactions are balanced. Now take the question number 2 in your book, page number 109, the question number 2. So you take it and do it, pause the video, then in the next part I show the answer, right? Before going to that part, you do it and go to that part. Right now, look at the page 109. There is a question to write the 2 half equations for the following reactions and to write whether the half equations are oxidation or reduction. So first you write those and answer it to question number 2 part A, right, page number 109. Then look at the answer where I explain it. So this is the first one. Chlorine reacts with iodide ions and iodine form. So iodine and chloride ions are formed. So the two half equations are, we can take this first. Chlorine will become 2 chloride ions. So that means for chlorine you have to add 2 electrons. So chlorine obtain 2 electrons means it is a reduction. And iodide ions, 2 iodide ions are there. So one iodide ion can remove 1 electron and becomes iodine. Like that, these two remove 2 electrons and become iodine. Now you can see that removal of electron occurs here. So this is an oxidation. Okay. Next one, magnesium reacts with oxygen to form magnesium oxide. So one, I will take magnesium. So here magnesium ion is there. So magnesium 2 plus ion. So that means magnesium has to remove electrons to become magnesium ion. So this is a reduction. Sorry, this is an oxidation, right? Removal of oxidation. The next one, oxygen will gain electrons to become oxide ions. So it gains 2 electrons, but since there are 2 atoms, 4 electrons, so this becomes, okay, so that's a reduction. And since there are 4 electrons to balance, we can multiply this by 2, right? Then 4 electrons and 2. So number of electrons are balanced, then the balanced equation. So those are the 2 half equations and whether they are oxidation or reduction. Next one is iron with oxygen. So here iron oxidizes. Iron remove 3 electrons and oxidizes. So this is oxidation, right? And oxygen become oxide ions by reducing. Oxygen become oxide ions, right? So that's a reduction. So it can be written like this: now here 2 oxide ions are formed. Because of that, 1 oxygen atom removes 2 electrons. So both oxygen atoms remove 4 electrons. So I made a mistake. Gain, right? Oxygen gains 2 electrons to become oxide ion, and since this is an oxygen molecule, 2 oxygen atoms, 4. So that's the reduction reaction. Oxidation and reduction we can leave like this or balance. You can see the electrons are 3 and 4, so that the LCM should be taken. Least common multiple should be taken. That is 12. So to become the electrons 12, to make the electrons 12, we can multiply the whole equation by 4. This to make 12, we can multiply it by 3. So this becomes 12, 3, 6 there. So that can be given as the oxidation and reduction reactions there. Page 109, the second question, part B, is this, that it says the 2 half reactions are given. Here 2 half reactions are given, half equations are given, so that we are told to write the balanced chemical equation using this. Now you can see in the book zinc, the electrons are given in the other side as zinc 2 plus and plus electrons in this side, but I put it in this side to show that it's whether oxidation or reduction. Now here gaining of electron, it's a reduction, here an oxidation. Now we know how to balance this to make these two electrons equal. So this is 10, this is 2, LCM, lowest common multiple is 10. So just we have to multiply the second equation by 5. Okay, so I can write 5 into 2, 10, here 5. And just add them together, then electrons will be cancelled, plus and plus, minus. Sorry. So that collectively we can write this as 2 iodide ions plus 12 hydrogen ions plus 5 zinc atoms. This side iodine, water and 5 zinc ions. So that will be the balanced ionic equation of the reaction. Right, our next topic is oxidation number, or we call it oxidation state also. So the definition is definition is given here. So you can write this: the number of electrons removed or gained by an atom in a compound or by an ion. So the meaning is atom in a compound means, now as an example, if water molecule is taken, so hydrogen atom and oxygen atom are the atoms. So by an ion, so in sodium chloride, sodium ions and chloride ion, completely or partially removed or gained, completely or partially. So that I just change it, the number of electrons removed or gained completely or partially by an atom. That's better. Completely or partially. Here, write it here. Completely or partially by an atom in a compound or by an ion with a positive or negative sign based on whether it is a removal or gain. Now we know that if zinc remove electron, zinc 2 plus ion is formed. So 2 plus means electrons are removed. Positive sign is for removal of electrons, while negative sign is for gain of electron. That completely or partially means, now if hydrogen and oxygen are considered in water, they share the electrons since that is a covalent bond. So that is partially, they have removed or gained partially. And completely means like when an ion is formed, right? So that is called oxidation number. So now as an example, in water, oxidation number of hydrogen is 1, oxidation plus 1, oxidation of oxygen, oxidation number of oxygen is minus 2, like that. Now we are going to discuss the next part, oxidation number rules. So I'll go according to the book. The first rule, it says that the oxidation number of any uncombined element is 0. So that has to be remembered. Any element in the normal natural state. Now as an example, if you take iron as atoms, then if you take oxygen as molecules, ozone molecules, nitrogen molecules, like those, and something like sulfur S8 molecules, like those, right? So any of these, the oxidation state or the oxidation number is 0. Oxidation number is 0. So that is the first rule. Then the second rule, some groups have fixed oxidation numbers. As an example, group 1, which contains sodium, lithium, magnesium, cesium, like those things. So that those have the oxidation number +1, group 1 plus 1. Group 2, like magnesium, calcium, barium, those things, so that they have the +2 oxidation state, most probably. And remember, fluorine, most electronegative element, so always -1. Hydrogen, if you take, in most of the compounds, hydrogen has +1, but some metal hydrides, like this sodium hydride, sodium plus, because it is in the group 1, always plus, so this has a negative oxidation number -1 in metal hydrides. And the other one, oxygen. In many compounds, oxygen has the oxidation state -2, but there are some other states called peroxides and superoxides. Now look at this water. Here oxidation state is -2. This one, oxidation state of oxygen is -1. So this is peroxide, hydrogen peroxide. Now this is sodium oxide, right? This is sodium peroxide, because this is +1, this is -1. Sodium peroxide. So in peroxides, the oxidation number of oxygen is -1. And there are other type of oxides called superoxides. Now here +1, here +1 of both, that means of one oxygen atom, the oxidation state is -1/2. So -1/2 comes for the superoxides, right? They are called superoxides, right? Then it says oxidation number of monoatomic ion is always a charge. That is correct. And the other important one is, if a compound is taken, any compound taken, or as an example, I will take sodium hydroxide. Okay, so the oxidation number, the sum of oxidation numbers of this compound is 0. That means here of oxygen, sodium is +1, oxygen -2, hydrogen +1. Now you can see +1 +1 +2 -2 is 0, like that. So the sum of the oxidation number of any compound, calcium carbonate. Okay. Now here if you take, this is calculated in a different way. Look at this properly. This is +2. This is -2. But actually we have to take the whole thing. So that of calcium +2, of oxygen 2 into 3 -6. So to be 0, this should be +4. So oxidation number of carbon is +4 here. Okay. Consider this compound, this sodium dichromate. So here the sum of the oxidation numbers should be 0. So we take like this. I separate. Upper side I will put the oxidation number of the element, the ion. Then down I am putting the oxidation number, collective oxidation number of that. So here +1, here -2. So if we don't know of chromium, this is -2 into 7 -14. This is 1 into 2 +2. Now we know that the sum of these should be 0. Here -14 plus 2 is -12. So to balance, this should be +12. But since there are 2 of one chromium iron, that the oxidation number should be plus 6. So the oxidation number of chromium in sodium dichromate is plus 6. Sum of the oxidation number are taken from this, not by these, right? You have to multiply by the number of atoms 2. Rule says the sum of the oxidation numbers in an iron is equal to the charge of the iron. Now look at this, you take carbonate iron, right? So that if the carbonate ion is considered, sum of the oxidation number is minus 2. So look at this, right? This is minus 2. So because of this, minus 6, right? Since the sum of the oxidation number should be minus 2, this should be plus 4. Then only you get the answer as minus 2, right? So we will take that dichromate ion. This is the dichromate ion. So oxidation number is minus 2, right? So Cr47 minus 2. This minus 2 is the oxidation state of the iron. Oxidation state of oxygen is minus 2 into 7 minus 14. This should be plus 12 then. Why? The sum should be equal to minus 2. So of 2 plus 2 of 1 plus 6. Okay, so that's the meaning of that. Then it says in either compound or ion, the more electronegative element is given the negative oxidation number. So this is more electronegative than this, so it gets the negative oxidation number. That's the meaning of it. So those are the rules of oxidation numbers or states, and how to find the oxidation number of an atom in a compound or ion in a compound. That's how you find the oxidation number. So you have to memorize those rules. So I explained it here. You can write in the book if you need. Next you take the question in page number 110. There is a question to find the oxidation states of the atoms given. So that you do those questions, then look at the video, watch the video for the solutions. Okay, the first one is P2O5. We had to find the oxidation state of phosphorus here, right? So separate it. Oxidation state of oxygen is here, minus 2. So minus 2 into 5, minus 10. So since this is a compound, the sum of the oxidation number should be 0. So this should be plus 10 then, of 2 plus 2 of 1 plus 5. So the oxidation state of phosphorus here is plus 2. Then of sulfate ion. Now since the charge of this is minus 2, sum of the oxidation numbers is minus 2. So separate it. Of oxygen minus 2, 2 into 4 minus 8. To be minus 2, here should be plus 6. Then the total becomes minus 2. So only 1 is there, so plus 6. So the oxidation state of sulfur is plus 6. Next one is a compound hydrogen sulfide. Separate it. Hydrogen plus 1. So here plus 2. To be 0 minus 2. Of sulfur here, the oxidation state is minus 2. Oxidation number is minus 2. Next one, aluminium chloride. Separate. Chlorine minus 1, so minus 6. Here it should be plus 6 of 2. 1 aluminium plus 3. So the oxidation number of aluminium here is plus 3. Ammonia compound, so sum is 0 plus 1. So here plus 3 to be 0 minus 3. So here minus 3. Nitrogen oxidation number is minus 3 here. Then iron oxidation, sum of the oxidation numbers should be minus 1. So of oxygen minus 2, 2 is minus 4. To be minus 1, this should be then plus 3. Right? So here plus 3. Okay. So when something like this is considered, we look at the chlorine and oxygen. So oxygen is more electronegative. Because of that, we took it as this. Calcium carbonate, try to find of carbon. So sum of the oxidation number is 0, minus 2, minus 6. So here plus 2 because this is group 2. So to be 0, this should be plus 4. So here plus 4. Oxidation number of carbon is plus 4 here.